So, hello everybody. My name is Hedayat. Holochain-in-Action meeting number 3. Thank you for coming, and for the visitors or anybody that's watching us in YouTube. First of all, review the previous video. It is the number 3. We started peer share, actually implementation of peer share. So we already did checking, and we are going to review about this session, what is waiting for us. So it is okay. I'm going to share my screen. So here, so it is generally the content of today, mostly. It means today, recently, a few times I was asked, and why Holochain use Rust, and especially in the open space, last meeting of open space, again, we had this question, and a few times more, others also asked me, around me, the people in the private chat, something. So we are going to review quickly why Rust, and also for that, we need to take a look at the Holochain, how Holochain generally runs hApps. And then before I start, I'm gonna talk a little bit about the modularity in Rust, how we can create the modules, because generally we are not putting everything in every function in a simple file. So we are going to create a modularity. In Rust, different modules, sub-modules, a little bit tricky. Let's review it at the beginning. So for the future, reading the code, maintaining the code is going to be much more easier. And also, we can also refer to this video. I think it's good and helpful. And today we are going to do a progenitor pattern with some tests. Just we put some property inside the DNA to see how we are implementing the progenitor pattern. Yes. The English guys, please correct me if my accent is not good, please. So, and during the test, we need to override the property and test it. Also, again, bunch of topic about the unwrap. They are Rust, they are not Holochain, but if we can cover them right now, for the future, it's going to be much more handy to just write the code and continue. What is the big difference in unwrap and question mark in object? So it is the overview for today. These two topics, it means why Holochain use Rust and how Holochain run application. So again, I'm inviting anybody, just interrupt me and add extra point, or if you think I'm wrong, please correct me. So to answer this one more precisely, we need to look at the Holochain architecture, how it is running. Generally, for those of you with less knowledge than others, I'm going to explain fundamentally how the things are working. At the end, when we are implementing Holochain application, at the end, there should be, let me silence my mobile. Yes. So at the end, it is the conductor is going to host on our application. So it is the, no matter it is on mobile, browser, PC, tab, anything, at the end, we need a conductor that is going to launch our application. So there are some job for conductor, something, and as you can imagine, we are not supposed to deal with all functionality and a framework level in our application. So like a peer-to-peer connection, communication, different flows, the workflow that's happening behind the scenes. So all of them are supposed to be hidden. Something, even you see something like even Solidity in Ethereum. I don't know if it is changed or not, but yeah, you write a smart contract, you just publish your contract. So I'm not following Ethereum anymore. If it is changed, I don't know, please correct me. By the way, generally it means our application has two layers or two levels actually. There is a core layer, this application that we are implementing, and it is the holochain layer. The application that we are implementing, like peer share, the things we are implementing is a conscious layer that has been written or has been written by a developer we are implementing. And there is a core layer. So subconscious layer that all the protocol level, all the complex and complicated flows and functionality happening here. And we are talking to this using the Holochain Development Kit or HDK. So generally, it is mostly, I can say it is the future. It means most of the time there is a framework running our application. So it is the way the things are working. It is a DNA network. It means any DNA has its own network. I think it's obvious. Is there any point till now or any question or any extra explanation that I can continue then? That's it. So then I can say why Rust? So as you can see here, it is the core layer is the layer below, actually, low level. The low level doesn't know anything about the higher level. So it means programming language or any application, generally it is the memory management. At the end of the day, one application just doing memory management and process, that's it. So why Rust? In a nutshell, the best language that can guarantee this layer can build in a way that it is safe in memory usage, so that can guarantee that the compiled application that's supposed to be run and executed by the core layer, it is safe enough. So I can say the only, if you know other programming language, please correct me. I can say right now in the market, the only programming language that can do this job, it is Rust. In a nutshell, we can categorize all the programming language from a right side to high-level programming language, that the memory management happening by a garbage collector, to the low level, which is C++. One example, the memory management should be applied by developer. So Rust exactly is in the middle, using the ownership logic. During the compile time, it will review all the memory and stop you if there is any memory leak, and it totally take care about memory usage during the compile. Actually, it means if there is some issues in memory management or you are not using a memory correctly, you would receive error compile time. For sure, there are some exceptions. You can pass through some rules and you can implement a code by your responsibility. We are not talking about some exceptions actually. It means in Rust language, when your program compile, core level can be sure that you are safe in memory management. All in all, as you can see recently in the market, especially in the crypto market, many projects started to convert it in Rust language. That's why it is the beauty of Rust. So from my side, it is, I think it is enough. If anybody see this video right now can receive a general idea of why market using Rust, what's happening. If anybody else would like to add something, please. Yeah, please.
Yeah, I can add that right now Holochain Core doesn't really assume that the applications are written in Rust. It assumes the applications are compiled to WebAssembly, which is not exactly the same, right? So you can write applications in Rust and then compile them down to WebAssembly, but you can do so in other languages. right now the HTK is only written in Rust. That's true. So right now, it's only possible to write applications in Rust. But Holochain core doesn't have to change one bit for it to support other languages as well when new HTKs are provided. It's just, I just wanted to make clear that in the future, we may be able to write in languages other than Rust when other HTKs in other languages are created.
Thank you. Exactly. For sure, at the end, we are generating WebAssembly, which is supposed to be run in a browser, but Rust and other programming language that can generate WebAssembly, as Guillaume mentioned, it can be hosted or run by the Holochain core. But Rust has a unique position that can guarantee it is safe, and that's why we started from Rust. And core already implemented in Rust, but that is totally true. Any programming language that generates WebAssembly can be hosted by Holochain core or can be applied. It means in the future you can, maybe it depends. You can use C# or Java to write your code, generate WebAssembly, and then use it. It is possible. But as I mentioned, the beauty of Rust, it is because of the guarantee for a memory bank. Thank you, Guillaume. Okay, so this is the first two topics. Let's go to the actually modularity in Rust. We are still not reached to the Holochain, but we are going to review modularity in Rust. Let me come here, share. Okay. So do you remember it was the latest version of project that we implemented so far? It was a really simple startup of a who am I zone function with a test that you can have it in Holochain-in-Action peer share in GitHub. So before starting Progenitor Pattern, let me explain a little bit about modularity in Rust, really quick and really soon. Generally, if you need to have one module, for example, example.rs. So the example of RS, it is a module. The module is by name, you know. If you have a public function something, so if you would like to use this module, you just need to go mod example. That's it. It is the way that you can easily use the something. So it means your module should have the name and the module, the exact name of the file. It is the module name actually. So it's too obvious. So the issue here that we have that we are not going and we are not supposed to put all our functionality in the same level and in the file. So there is another alternative way that you can go for the folder. What does it mean? It means example.rs. I already have example. Let me change it to, for example, I want to have example2.rs. So for the better namespacing or modularity, I would like to have a folder. Here, this method that you need to have a mod.rs. So instead of having the file name, you create a folder and mod, okay? Pub fn something to, that's it. So, and here you can use module example2. So, and is mod anything if you would like to bring here, for example, let's say some, give me the name as an internal module, for example, something 2.rs. Okay, so if you have a function here inside, like a pub function something 2, so to bring it up, you need to put it here. Actually, it means pub mod something 2, and then reuse this one as an example here, mod example 2. So
you named the directory example2.rs. That's why
I didn't get you.
the name of the directory is not example2. You named it example2.rs. That's why you should rename.
Yeah. It's example 2. Yeah, you are right. So let me come here. So just imagine pub fn something 2 here. And let me also remove this one. Yes, that is true. It was my mistake. As you can see, so it means I want to have example 2. I put the name on the folder. In the mod, I create the something 2. In the lib, which is the root of the caret. It means if you have any module you would like to bring it up to the whole your library, you need to define it here actually. So as you can see here, I can call example 2 something 2. So that's it. It is generally the two general way that you can use this both logic for a modularity. It means on the name, or you can be on the folder and a mod. The way mostly I'm going to use it is, or a lot of project using it, is the mixture of both of them, because also we can have a how can I say, we can have a sub module inside that make it much more easier. It means, as I showed already, we can say sub module dot rs. So fn pub fn sub module here. So, and I can say in the mod, which is bringing everything to the example, I can define here pub mod submodule. So, and then by defining here, it's going to be available in this example. It means in the lib, I can easily use the example to submodule and any function inside. That's it. It means the whole concept. I explained that you get the point. How to reuse any module, if it is submodule, how we can use it, because it's somehow confusing for those of you that you are not a Rust developer and you already started learning Rust. This modularity can be a little bit confused, and I decided to explain at the beginning how the things are working. Any question, any topic? Or adding anything? Okay. Thank you, Lucas, for supporting and helping. Okay. That's it. I would like to continue. So let me remove this example, delete. So let's start our Progenitor pattern. I would like to have some helpers. Inside the helper, we can have a different utility or helper that we need for the future, and that's why I'm creating helper. By the way, guys, I have a bunch of things here. If you see somebody coming for the admit, let me know, please. Somebody waiting in a waiting room, just interrupt me. So I'm going to name it progenitors.rs. So it means this one is going to be our module, and I need to bring it up, as you saw, mod.rs. So let me come here and show this one. Progenitor pattern. What does it mean? It means we need to, what was the reason of this project, the PSHA, that we can create the abstract layer as a definition, a schema definition, that anybody cannot change the schema definition because it is the schema or abstraction level of data definition or a modeling actually. So the only person can change this one is a developer of the system. It means if I'm going to publish the PSHA, it is me, the only one can publish the, let me come back. So yes, it means it is only me that I can publish the, or I can change the schema definition, and I can add some record or some entry to DNA and something like that. I need to put my public key that I'm going to publish using that public key, so that I'm using, and the name is progenitor. So this one is supposed to go to the DNA property. So it is fixed. It's going to be overridden using when we are adding, when application is going to be run for the first time, and nobody else, as we mentioned earlier, cannot change it. If anybody else can change or fake and put its own public key inside, hash is going to be changed. They are going to be in totally invalid network, and they cannot communicate to others. The whole pattern is a progenitor pattern. So, and we are going to start learning and implementing this one, and implementing also the test. That's it. Any question? So it means, first of all, I need to go to the work directory. It is the DNA, yes? Inside the DNA, we have a property. So in the property, I would like to add one property name, developer address. So you can add as much as property you would like. So it is the hard-coded public key that I just copy and paste. It can be any string because it should be overridden during either test or even publishing application. How we can do that during the test, we will see today. For bringing up one example with the conductor later on, we will discover how it is possible. But right now, I just copy and paste in key generator and one public key to make it more sense how the thing is supposed to be working. So when we are, so it is the place that it is the place we need to put any property for the DNA. Then in the source code, in the progenitor, I need to, like always, use HDK that preload a star. This is mostly we use, and for the first time, let's go to preload to see what is preload. Preload mostly bringing the most required, the most usable and required functionality from HDK core actually. So it is from preload. Mostly if you use a preload, most of the time you are good to continue with others. So pub function. So for loading this DNA, reading the DNA, actually, you need to read the block and cast it to the object. It means you need to have, I'm going to call it DNA properties, actually. DNA property, top developer address as a string. That's it. You need to implement and create a one struct peer-to-peer with this property. It means if you have something like something else as true or false Boolean, you need to have this struct, something like pop something else Boolean.
Sayed,
Yes.
It's a struct, not a function. That would be a bit.
Yeah. Struct. Sorry. Thank you. So this struct, it is loading for. I'm gonna use as a DNA property. So how to read it? Let me implement for DNA properties something like public function get. So what is returning? It is self. So zoom info from this preload that you can see dot unwrap. It means open it dot properties dot try into that unwrap. Generally, it is the way you can read the DNA property. So you need to go to zoom info from the property, try into cast to DNA property and just unwrap it. First of all, one point that I mentioned about the unwrap and question mark, I'm gonna cover this one at the beginning, that what is the difference when you're using unwrap, is it good to use unwrap or not, or question mark that here. So I will cover it later actually. So that's it. Right now, let me also bring the comment for running, for building the DNA.
Why are you unwrapping twice?
Because this time, the zoom info, it is the, look, this is unwrap. What does it mean, unwrap? Or unwrap means anytime that there is an external result. It means zoom function return back the external result. I need that one, and then go to the properties, and then try into also, which is the result. I'm unwrapping to this one actually. That's it. It is not a big deal actually. So, but let's that's it. Did you receive the answer, Thomas?
Yeah, please continue. Thank you.
Yeah, sure. So, look, guys, it is important. I'm going to show you. If you are going to build right now, generally, let me clean up the project from this one, this one. So it is building pretty nice, but it is not supposed to be right, because if you are writing any code you are building, it is safe. It doesn't mean maybe right. You need to use it. You need to actually define that, bring the code. Code right now is dead code. You need to bring it. And how a mod, it means define a module, helpers, and right now it is enough. From the helper, I need to pop mode progenitor. That's it. I'm building right now. So it's good news. So serialization, actually, it means the trait into needs some serialization actually. So because it is casting and it is supposed to go for the implementation of the actually the interface that's supposed to convert the object to the object that I asked. So it's supposed to have this serialization. So I'm going to bring the whole serialization here, that it is attribute based. Mostly we are all the time, not all the time, mostly when we are defining a struct, we just copy and paste. It is the attribute based, serialized, and debug and kill on. Mostly maybe we need to do it step by step, but we can have it here right now. But it is better to have a step by step. When you need debug, go for debug. When you need clone, go for clone. But I'm just copy and paste to go continue step by step. So that's it. So it means the code is built. Right now I can say read property to the object. Is there any question so far? That is great. So one small point, maybe you would say zone info, it is a correct place to have a DNA property. If you have this question, please hold it on, and later on, maybe today, maybe another day, if we would have enough time, we would come back to this one to see, is it a good place to have a DNA property in zone info? Let's continue. Right now, I really would like to have a zone function, the zone function, to return it back. Return it back. So it means for the zone function, I need to create one external function, public function. So let's call it, let me see how I called it before. Okay, get DNA property. It means get DNA props. Input parameter is nothing, as I explained previously, that if it is empty, you are not supposed to send any parameter, write it in that way. So external result, DNA properties, and for sure it is not building, and we need to add this one. It means it's suggesting, and it is nice. From helper, progenitor, DNA properties. So it is an external result. I need to return back. Okay, that's it. No, this one also. What?
Yeah, it's external result, not external result.
It is external. Thank you, Guillaume. Yes, external result. Hello, external result. Yes, that's it. Let's build to see. Wow, it is building. Really easy. So let's go and implement test. If there is not any question so far, let's go and implement test. Source, I'm going to create a new file. I'm going to call it progenitors.rs. So let's go and copy and paste something which is, let me copy and paste everything here right now. Oh, sorry, not RS. Right now we are in a test. It means TypeScript TS. So I'm going to, let me check, is there anybody in waiting room? No. So yeah, I just copy and paste all the code here in who am I. So as you can see, we load a common, we created Alice cell. I'm going to remove this section. We will clean up step by step these classes, okay? But just let's continue to see how the things are working. So right now I can say, call the zone function. So let results equal wait, Alice cell, call the zone, it should be zone name, Piaget, it should be zone function, get property, it should be argument, sending argument, which is null right now. So what was the zone name? It's supposed to be, I think we put it in the common, yeah? The zone name Piaget. We are not copy and paste all the time, this Piaget as a hard-coded text. Maybe we would like to change it. So I'm coming here in the tier, I would say, bring the zone Piaget, you know, it is just a constant. That's it, nothing special. So zone name is Piaget zone function get DNA properties. Get DNA properties. So it's going to be resolved. Like always, I love to log everything that I have. It means read DNA properties with result. And then to have a deep copy, let me change that TDB quad. Okay, TDB. Let me copy and paste. It's fantastic. So TDB equal very good. What happened? I was changing it wrong.
You copied all the text.
So who am I? Sorry, yeah. TDB equal progenitor. So I'm telling I would like to have a result. What is result generally, guys? The result is the result DNA property, but we need to read this property from the object, you know. So progenitor result point developer address because it's written like object, and it should be equal to what? Generally, right now we put hard code. Yeah, we did hard coded value in the DNA properties. So let's go to the property. Where was it? Okay. DNA property, this one, it is hard coded. Right now, we are going to change it soon. So if Alice calls this function and this function is passed, it means everything is working pretty nice. The last point that the index is running, you know, I need to bring up the code here. Let's have an orchestrator, new object of orchestrator. So require, so progenitor and orchestrator, so and orchestrator dot run. What does it mean, guys? It is not a big deal. Let's go to the progenitor again, to the test. What this class, this TS file or TypeScript do at the end, it is module expert, this one. What is this? It is a function. The anonymous function, the function that receive a parameter. Anybody open this file supposed to have actually the function that waiting for a parameter. Here, the same. We are loading the object. It means from here, the object is coming up. When it's coming up, there is a function. The name is function, we don't know. It is an anonymous function. It is waiting for the parameter. That's it, is the meaning of this line. That's it. So if you would like to actually speed up, you can, anytime you can comment your old code, old test which is running and just run your test. But right now I'm gonna run all of them. npm test. I didn't save anything. Mm. Oh, maybe I didn't say it again. That's it. To test one pass, read DNA property, exactly read the DNA property. It means we finished quite well the first step of generating and putting something in a DNA and reading inside the zone. So again, why we need this functionality? To know who is the developer, who is the admin user. The admin user is going to be identify himself by the or herself by the actually the public key. I'm going to continue to detect this ID is a developer or not. It means when I'm running one instance of application or I'm running one application as a cell, we are calling cell, and we are going to explain what does it mean cell. Why later? Right now, in the conductor, you can have a different identity or different public key. For each public key, you can install one application. We are calling it cell. It means just imagine how do you have a different profile in Instagram? You generate a different email and log in with that, sign out, sign in, sign out, sign in. In the Holochain world, you can have a different public key and pair key, public and private key for each of them. If you install one instance of application, conductor see that one as a cell. It means one public key, one instance of the application or DNA. It is pair key. So the next level, when the application is coming up, you have one public key. We are supposed to detect the user which is sending the comment is a developer. How to do that? To compare the property from a DNA developer address with my public key. If they are equal, I'm a developer. If they are not equal, I'm not a developer. Any question? Should we continue?
Yeah, thank you very much. I need to jump off to another call, but thank you very much for this lessons. It's great. So see you guys later. Bye bye.
I'm gonna pause for 1 minute rest and come back. The recording for sure. So we came back after a short break. So what I'm going to do right now, again, that for the people for the first time, I'm going to explain this topic, unwrap. I saw also other spaces that people asking unwrap question mark. It is a Rust level, but let me also cover this topic right now and what is the main topic. Just really quick one. What is the difference between unwrap and question mark? Really quick. Just imagine that we have function read file. So here I can say use std fs file. So I let something equal open a file in path. Okay, so right now unwrap, what does it mean? There is a function and the code can be. So there is a function telling, hey, read a file with this path and unwrap. Unwrap means open, return the result, as you can see here. Can you see results here? So unwrap means open this, as you know, result can be okay with some content or error. So if it is okay, unwrap the content, assign to something, otherwise panic. It means stop working with some explanation from the stack of this line or the situation here and panic. That's it. It is the meaning of unwrap. As you know, Rust doesn't have specifically or generally, it is the exception handling safe, or there is no special exception handling. All the exception handling supposed to be covered by developer. There is no even try catch. So we will see how we cover those things. But what is the look? There is also comment here. What does it mean and what is the difference? So just imagine there is a we have a function in the normal actually Rust the main, we are calling this one. Just imagine this function is sub function. It means inside the parent you are calling this one. If it is the unwrap, if file is not existed or anything, we are gonna have panic. But we cannot do a special exception handling here. But just imagine function read file, for example, 2, and here we can return results with, for example, a string and error. And error because of file, it should be stdio and error. So this error is error. So here, right now, I can use question mark here, and here I can say, okay, with something. So I can use question mark here. It means question mark here telling if the file exists, there is no problem. Just put unwrap the content, put it here. If there is error, not panic, return back or propagate error to the upper level. Upper level means the parent who called this function. That's it. A really important point here that the function that you are writing, this one is really shorthand, should implement the same error that it means this error with the same that your function return back. It is really important. It is the key. So if you see unwrap and if you see this one, it is the whole explanation. Which one is better? For sure, this one. It means you already handled your exceptions. You are a good developer. It means you guarantee the code is much more better and safer, actually. Unwrap, you have a good potential for the panic and software exceptions and etc. So generally, these both, they are the difference between unwrap and this one. As far as possible, please do not use. I'm gonna use for somehow showing something, somehow I'm getting lazy, but do not do it as far as possible. And I'm going to implement and change this one to this one actually. But right now, is that clear? Is there any question here? The difference between unwrap and question mark.
I think I understand the difference, but I'm wondering, why don't you show the error handling with the question mark? Like, so if it's you do a match on the result, and if it's okay or if it's an error, then you have two different paths of execution. So,
yeah, sure. Actually, it is a shorthand.
I mean, this is for beginners Rust, right? But if people don't know, maybe that would be helpful.
Yes, thank you, exactly. So it means this one is a shorthand of the result. You can go pseudocode. Yeah, I'm going pseudocode. Switch case or match. It is better match if it is okay. Do something. It means something with a value. Otherwise, if it is error, just return error with message. That's it. It means instead of writing the whole match case, we are writing this one. That's it. I explain on purpose unwrap and this one because I'm sure you are going to clone a lot of repository in Holochain. Most of the time you are asking, why here this one? Why another one is unwrap? When we are writing a fast code, we are just somehow to speed up, we are writing unwrap, but please do not do that. That's it. Should I continue? So just imagine here, let's just go for unwrap. Look, I cannot change it to this one right now. Why? Because it means return back what? Return back the error, but this one is not returning back error anything. So it means if I would like to go and implement a nice one, external result. Yeah. So I need to say, hey, for me, it is external result. That's returning back self. So, and trying to right now, it is let prop. It is DNA properties. That's it. It's converted. Let me run that. You see that it is running. It's returning back external. It means here I don't need any more. Okay, actually, that's it. Oh man. Example I created. Bam, passed. That's it. It is the way for implementing. If you are putting with something with error, just consider this one. If there is no question, I can speed up with the implementation of the rest.
I would want to make one point about unwrap actually,
please.
Which is it is not enough to have the test passed with unwrap and say, yay, like this unwrap is fine because it's unwrapping an okay value. So the code is fine and we shouldn't no, it's not okay because Holochain being distributed and having multiple execution context and multiple, like a get, I do a get and it's not the same get that hApps does, right? And if I do unwrap and in the test, it's fine, but hApps, the day that is in production, does the unwrap and it's an error, it's going to panic there. And in Holochain, there is no sysadmin that goes and fixes production code. In like that's not a thing, right? You have to actually upgrade the DNA. So we have to be careful with that.
That is great. Thank you. Guys, I can continue to implement. Am I a developer to read everything with the test, or you think it is enough for today and it is a lot of content? Or we can finish a progenitor and for the next session we can continue. What do you think?
I'm okay to continue.
Okay. I'm going to actually here. So I'm not sharing my screen. Wait. Let's wrap it up everything in the progenitor actually for that from the next session we can continue with other topic. Can you see my screen? Yeah. So here, and we are going to have. Yeah, let's continue, but it is a little bit more content. But let's see what we want to have right now. Public function get their address. I'm going to expand, implement on DNA property with dev. So it means it is the function. Just right now, give me extend result, or I would like to say extend result maybe with pub, actually agent pub key. So here, here we just read the properties. Here I'm going to convert the property to the agent pub key. It means what we are going to implement. We are going to implement something like that. Let's see what we are going to achieve. We are going to achieve public function. Am I developer? Extend result Boolean unimplemented, or let's say just right now, just return or okay, you know, both of the same. True. That's it. But here we are going to implement this one. For this one, I'm going to implement something like this, that we have a public function, am I developer here. It received nothing. It returned extend result Boolean. So right now unimplemented. What we are going to do, we are going to actually get property, get developer address from DNA property, compare to my current pub key, or developer key. It is better developer public key. If it is equal, I'm a developer. If equal, I am a developer. Otherwise, I am not. It is the logic we are going to implement. So it is not the big deal. It can be also a good option for more challenge. But as I see in the code and test, here we have something I really would like to drill in about the hash of the entry or hash of the public key. And there is a challenge. I am skeptical to start that challenge because we are already 1 hour 20. I really would like to postpone to the next week. And I'm going to push the code. I'm going to put to do, and maybe to do is nice. Some people would like go to implementing to do and practice. I was preparing the content that I can cover today, but it seems it is a lot for today. Let's go for the next. What do you think?
So it's basically from Triorama. Yeah, I understand. Like you want to actually test the progenitor address from Triorama.
Yes. Yes.
Yeah, I agree.
Yes. Let me also mention for the people, if you would like to look at the practice. So it is unimplemented. Let me put unimplemented. Maybe some people like it. Let's see what's happening. It is from a zone. It means from a library unit. It is there. I'm going to push the code in that way. It means, let me also unimplemented. It is unimplemented. So, but it is not the big deal. This one is calling this one progenitor class. Here, we are going to convert this property of DNA to the agent pub key, and then compare to the current address. Look, we already know how to read the current address. This one. We need to compare these two ones. Yeah, it's really easy here. But we have a little bit challenge in testing. What does it mean? In testing, when I'm going to test it, let me go to, for example, progenitor. So right now I read the property, so I can compare. But in this one, we need, when we are generating we are installing the agent, we need to say, hey, the public key that you are generating, you need to overwrite this DNA property on demand. It means this one, anytime the test is running, one new instance of DNA is coming up on the fly, and then the zone function are being called. The challenge here is that during the test, when you are going to test, or we are going for the next session to test this one, when we install the app agent, we need to say, hey, when you want to create one DNA instance, override DNA property with agent key. So we have an agent key, and we can override the property, and we can run it and compare that it is working or not. And that's why I don't want to continue this session, because this one with explanation and implementation and some base 64, it's challengeable. It takes more time.
Maybe I don't know if we've covered why properties, why DNAs can have properties, and why is I don't know if we've covered that. How cloning DNAs with different properties can give rise to different network.
Please explain, please.
Yeah, because it can give a bit of a context on everything that we are doing. So in Holochain, the base unit of both network and code and so on is a DNA, right? And the DNA is basically the rules of the game. Properties are a way of, without changing the code, configuring the rules of the game. So in PeerShore, for example, the progenitor is the admin agent. We are not changing the code. We are not changing the code that says the only one that can update these entries, the admin agent. We are configuring who is the admin agent, right? So those are two separate things in Holochain. So the code that you write in Rust can be configured via a property, right? Then the trick here, the nice thing is that if you change the property, then you change the whole DNA. So the hash of the DNA, which is the ID of the DNA, is with the properties inside. So if I install DNA with hash 1, for example, I'm already agreeing to playing by the rules of Hedayat as the progenitor in that DNA. I don't agree to only the code. I agree to the code and the properties. So then everyone in the network actually agrees who is the progenitor, because it comes in the properties, and everyone is running the same DNA because everyone is running the same hash. And that means that the properties that were input besides the code have to be the same. The cool thing is that now I can say, I don't like Hedayat. I'm sorry, we had some trouble.
It is a reality.
Things happen. I don't like Hedayat anymore. I want a new progenitor. Progenitor, I don't know. I want to create a network with me as a progenitor. What I can do is just take the exact same code, attach as a property my public key, and create a new DNA.
That is great.
That's going to create a new hash, and now I'm playing by these other rules, which are exactly the same as the old ones. It's just that now the configuration is a bit different, and now I'm the admin instead of Hedayat. Does that mean that everyone that was playing that old DNA has changed? Well, not at all. The only one that has that new DNA installed is me. So I'm playing a new game in which I'm the administrator, but I'm the only one playing it. So until I convince someone to actually, hey, this is cool, come play. I'll be the admin here. Come play by my rules, and I assure that there will be no problems. Then other people can install the DNA with hash 2, and then they will agree that it's me who is the admin. right? So you can think of all the possibilities that that brings. Not only the progenitor pattern is only one pattern, but in the properties of the DNA, you could put any kind of data. So I don't know, file size of the chunks. You could put the amount of people that are able to enter the network. You could put a whole range of diverse stuff. And then the flexibility is that the user is in control. Hey, I don't like this configuration, let me clone it. And there is no way to prevent someone from cloning a DNA, right? So yeah, I don't know. I hope that was clear.
Yeah, that is beautiful. Let me add something if there is a question. Just imagine there is a DNA with a game football. So many rules are located inside the property of a DNA as a standard FIFA rules of football. And you would say, you know, in our zone, we are not using this rule of football. We are going to change. Golden goal. Do you remember in golden goal, if you were in the extra time, the first team you would say, oh, golden goal is not there, but we would love golden goal. You would change the property. When the property is changed, hash of DNA is changed. When you run this DNA, you are running a new game. You are not anymore with that cell, as I explained, cell. Maybe you are also in the normal and standard football, but with this new one, you are alone. If your friends running the same DNA and hash with you, they are going to join you with your football with the golden goal. Your neighbors, your friend, your classmate, anybody, your friend or anybody accepted this specific rule can join you. As you can see with this property, you can easily fork the rules. You can easily fork software, DNA, and go and create your actually a network of a DNA. Mostly what is the best element that provide easy forking, not just forking. You are supposed to be a really deep developer to just change the code and fork. As much as you can put the rules, the basic rules to the property, anybody can change the rule and say, I love this football standard, but I would like to have our football in our city actually. You can go and create and fork. That's it. Thank you again. It was fantastic.
Even without changing the rules, it can be useful because, for example, if you have a group chat app, but I want to host and pay for the whole hosting of my group chat with my friends, we just have to change the title or whatever property without changing any rule. And that was something I was wondering. So I'm happy to have the answer.
Okay. Another question about forking the DNA. Does that mean that the application I install on my device, the one built by Hedayat, the initial one? So that's one application. And Guillaume changes the properties. So he has a fork. Do I have to install another application?
Yeah.
Okay.
Yeah,
Okay, I understand.
Yeah.
So I cannot have one application, like in the case of Lucas, a chat application, where I could have multiple channels on different DNAs.
Exactly.
So if I want 2 channels, I have to have 2 applications, even if they're the same applications.
If you build the chat app that way,
okay,
you could
In my
have
opinion,
a.
the way I thought about it is you could have a unique client that connects to multiple channels.
Yeah.
With the channels being their own software each.
Yeah, exactly. So you could, the way that you can do it is that you can build a chat DNA to have multiple channels. And then you can clone that chat DNA to be able to control who has access to the channels. So, and this maps a bit to Discord servers. So in Discord server, you create a server and there are multiple channels, and the people that you invite can see all the channels. So you can create a chat application in the same way. You create a chat DNA that can hold multiple channels, and you are in multiple chat DNAs. And the important thing about the DNAs is that they control, they have the access control. You can say who enters the DNA and who doesn't.
Generally, this facility providing more abilities for a different architecture. You can design a multi-channel of the chatting system in different way. One of the way, exactly, it is a multi-DNA for each channel. It is a kind of a design pattern inside your application. You are free to use your architecture in your application. But this pattern, it means properties inside the DNA, giving you a lot of abilities, a lot. And I'm sure again in the actually mutual credit, when it's going to be ready, you will see how much this ability provide facilities and patterns for a different community can easily bring up a new mutual currency or credit currency for their own community. They are not supposed to be actually a developer. They just need to change some property and then create their own pattern. So in the future, you will see more examples and the architect based on these DNA properties. Bam, bam. That's it. Beautiful. Guys, if there is no technical question, I'm gonna stop recording so we can continue. Or please, Roberto, please.
Just a quick one. Do you foresee like these patterns to be used? Like if I want to install a progenitor with a diet or with Guillaume, that I would actually type in myself the parameters so I get the DNA, or that there is a repository somewhere where you just download the whole thing?
Yeah, so there will be a hub store. So you will be able to download hubs from there, and then every hub can set up from the UI the appropriate way to clone, because the UI is a bit different maybe if I want to clone a group chat or if I want to clone a mutual credit, right? Maybe in the mutual credit, you want to be able to set the properties of credit limit or some fees or whatever, and that's not really the same as cloning a group chat, which is just whatever, I don't know, the administrator, right? So each UI can can set its own way of cloning once you've already downloaded the application.
So it's taking a long video, this session. So I'm going to say bye-bye to visitors, actually. So to YouTube visitor. So don't forget to watch the previous one. And also I cloned that one as a hello world, so that because we touched the repository, I just cloned that one as a hello world for the new guys, that they can go and see that video and to see how the scaffolding is working. And thank you for watching. Please, if you would like to participate in the meeting, go to the forum.holochain.org and fill out the application form. I'm going to put the application form in description also. So we are going to continue a little bit, but for you, just bye-bye. Thank you for watching and joining Holochain.